Let's play a game. I will say a sentence. This statement is false. Now you tell me, is it true or false? If it's true, then it's false. If it's false, then it's true. Welcome to the liar paradox, a loop that seems impossible to break. But today we're going to solve it with pure logic. Philosophy is not just asking questions, it's about solving problems. And in analytic philosophy, logic is the ultimate tool. The liar paradox challenges one of our core assumptions uh, that every statement is either true or false, the foundation of classical logic. But this paradox breaks the system. So, how do philosophers handle it? By asking, what if the problem is not the statement, but the system we are using to analyze it? Let's try to analyze it with classic truth tables. Let's call the sentence L. If L is true, then what it says must hold, but that makes it false. Here, if L is false, then it's lying about being false, meaning it's true. We are trapped. Classical logic fails here. So how did analytic philosophers solve this? Before we enter non-classical logic, I have to tell you three laws of classical logic. So, three laws of classical logic. First is law of identity. This means that anything is identical to itself. If something is true, then it's true. Second is law of non-contradiction. Like this. Here, A cannot be both A and not A at the same time, and it in the same respect. A statement cannot be both true and false simultaneously. Second is law of excluded middle. This has to be written like this. This means that either A or not A. Any statement is either true or false. There is no third option. These laws form the foundation of classical logic and are essential for rational argumentation and reasoning. Law of identity, law of non-contradiction, law of excluded middle. Three laws of classical logic. Now we enter non-classical logic, specifically paraconsistent and the three-valued logics. These systems allow a statement to be true, false, neither true or false, or in some cases even both. But this is not the real fix, because it does not solve this paradox. It accepts, like, this statement can be both true and false, or neither true or false. This is clear acceptance, not a fix. The most elegant solution came from Alfred Tarski. He noticed something crucial. The paradox arises because it talks about itself. It's self-referential. Tarski's fix is separating languages. Object language, where we talk about facts, meta language, where we talk about sentences themselves. In this system, a sentence in the object language cannot comment on its own truth, stopping the paradox before it even starts. Tarski's separation of languages gave us one way out, limiting what can talk about what. But there's another approach, one that dives even deeper into the very foundation of meaning and reference, type theory. Imagine language as a building, but every floor is a different type. On the ground floor, we have objects, things like cats, planets, numbers. On the second floor, we have properties, descriptions of those objects. Like, for example, the cat is fluffy. The third floor, sentences about sentences. And each level only talks about levels below it, never about itself. This is type theory, a system that builds a firewall into language itself. The liar paradox breaks the rules of type theory because a sentence is trying to comment directly on itself. In type theory, that's not allowed. It's a type mismatch, a violation of logical grammar itself. If you have ever written code, you have already used something like type theory. In programming, you can't assign a string to a variable expecting a number. That's a type error. Type theory applies the same logic to language itself, keeping statements from collapsing into paradox by restricting what types of statements can even exist. So what's the difference between Tarski's hierarchy and type theory? Think of it like this. Tarski builds a tower of languages, separating object language from a meta language. Type theory builds a system where statements themselves are strictly sorted into types, objects, properties, statements about properties, and they can't break the boundaries between types. Both approaches solve the paradox by blocking self-reference, either by linguistic separation or logic classification. Paradoxes are not glitches, they are opportunities. With non-classical logic, we expand truth itself. With Tarski, we structure language into safe layers, and with type theory, we design a system where some paradoxes simply cannot be formed in the first place. In the end, solving layer paradox is not just about fixing a quirky sentence. It's about rethinking how we understand language, truth, and even meaning itself. Paradoxes are what happens when the map does not match the territory, and sometimes the map itself needs redesigning. If you enjoyed unraveling this paradox, there are plenty more waiting to be solved, from paradoxes of identity to infinity and everything in between. So if you want to keep exploring the wildest corners of logic, let me know in the comments and we will dive into the next paradox together. See you next time.